But the
And
meanwhile, while you're talking on the phone, I just tried. As you mentioned, I just kept scanner.nextint. It
okay,
worked fine. It
okay,
seems that whatever you mentioned is correct.
okay. Yeah. If you give either two numbers continuously, or whether you give one number and then press enter, and then when you give one number and then press enter, it reads both of them same way. So it removes all the spaces and new line characters, everything, and tries to read the numbers and all. So that's how actually scanner simplifies some of the things. Okay, but it has that problem when we are actually mixing that up with new next line, when there is accidentally a chance of actually using new line character when the input itself. So now let me go to not files, save this, and
I have one more question.
yeah, sure.
Um, the scope of variables in the constructor class, is it limited to constructor sorry, constructor method itself? Because I defined one variable in that method. Uh,
Any variables that you create are limited to the braces that you have created them in.
okay,
Okay, so that's the typical simplest way of putting it. You cannot
okay,
access them outside. If you want to create use them outside, you have to create them as class variables.
class variables, right?
Okay, or in other words, fields. One exception is when we actually use a public. You can use those variables outside those classes also, but by using the object of that class.
Okay.
Uh, you understood that, or did I make you more confused?
No, the last line I did not understand. Could
Okay.
you please come again?
One exception to the rule that any variable that is created inside a parenthesis, the brace is uh, like I just said, right? Any variable that is created inside parenthesis can be used in that parenthesis only,
Correct.
but the class variables can be accessed outside by using the object of that class.
Okay.
When we created, say for example, the game class and the game object, so you will have to understand two different things: the class and the object. In fact, we'll cover more of those things today, and I'll try to uh, bring it in the topic discussion now.
Okay. Sure.
So, today we are actually trying to deal with a topic called as inheritance and composition. And from today onwards, we'll be entering into the realm of object-oriented programming. Okay, so far you are creating a class, and then that class is being used, having a main method, and that's it. Each class is independent of its own. But from today onwards, we'll create classes that depend on other classes, that extend from other classes, and also you see some concept called as interfaces, etc. So that we'll come to know how to actually reuse the code that has been written by other folks effectively, not by copy pasting, but by effectively extending the code. Okay, so right, by using or by writing minimal lines of code, we should be able to use the code that other people has written. Okay, and or extend or even change the behavior of the other people's uh, code. Okay, so all that can be done using these concepts called as inheritance and composition. So let's see what they are. And even before we go to that actual concept of inheritance and composition, so first we have to understand a concept of object-oriented thinking. What is an object-oriented thinking? Okay, imagine that you will have to eat. Say that is a problem that you are trying to solve. Now, what you will do? You will write a main method, and in that main method, you will put all the ingredients. The yourself. You will turn on the stove, and then you actually or add the ingredients in the right order as far as you know, and then you wait until that item is ready, and then you eat it. So that is a procedural way of thinking. Okay, and everything you do it yourself. Every work that has to be done, you are going to do that. Okay, that is actually not an object oriented thinking. But imagine this way: there is a restaurant, okay, which actually cooks food and gives it to you. Okay, so now what happened, that responsibility of cooking has been given to a restaurant, right? You really don't care how it is doing that as long as it is tasty. So you have to eat. That requirement is being satisfied by another object called as KFC. Okay, and and also KFC restaurant itself will not cook it, right? It will actually outsource that responsibility to a cook. Let's call him Bobby. So that food will be actually prepared by that cook, whoever is cooking, that actual person. He will do that job of preparing the food, and then KFC will takes care of sending that information to the cook, and taking that item from the cook and then delivering it to your home step. All you have to do is eat. So in the real world, most of the times, in fact, object oriented thinking is not that difficult actually. It is something that comes very naturally for us. Okay, say you want to get some things done, you don't do all those things yourself. Okay, you want to speak to another person. Okay, and what you do, you don't really convert your voice signals to some electronic signals and transmit that your and then other person will be decoding it. Won't happen like that, right? What happens is you are giving that responsibility to a telephone. The telephone object, how it is doing, you don't care, as long as it is delivering the voice clearly. So that telephone object is actually converting your voice to electronic signals and passing them to the actual telephone tower, and the tower will take care of passing that information to satellite, and then satellite will take care of giving it to the person who has to receive it. And there will be another satellite tower object, and then there will be another cell phone, and then there will be another person. So to communicate two persons who are two independent objects, you have telephone objects. Okay, two telephone objects. Each class has its own, each person has its own telephone object, and each area has its own telephone tower. And there is one central satellite which is actually coordinating all this communication between everything. Now, see, everything that you do is actually happening in object oriented way. So object oriented way, as many people make it, it's not actually difficult, it's actually pretty natural. Okay, that's how we think in the real world. We don't try to do everything ourselves. Okay, we don't try to make TV if we want to watch television. We try to go and buy TV, and in a TV showroom object will not actually create the TVs themselves. They will actually get it from some other third party company, like LG, Samsung, and even that LG, Samsung won't manufacture the TVs entirely. They depend on some other objects, like small the chips will be made by some company. PCBs will be made by some other company. The display retina screen will be made by some other company. Okay, all these things, so each and every work that has to be done in this real world will be distributed across different objects. Okay, in real world we don't call them objects, we call them organizations, we call them shops, we call them restaurants, we call them the showrooms. So and we finally what we get, we as an object get an object called TV. Okay, so that is how we actually do. So even when you are trying to program a problem, you always try to divide that problem into independent classes. Okay, what are all the functionalities that can be given to a specific class? Imagine you are a person. Okay, and so in object oriented terminology, you are an object, you are the real thing. And then person is a class. Person, say if you go to, if you search for person in Wikipedia, it will show, okay, person will have height, weight, he will have two legs, he will have two hands, he will have two eyes. All those attributes are defined, that's it. You can't actually communicate or interact with that person that is there in the Wikipedia. So person class is that, it's a definition of a person. Whereas you, when you are conceived and when you're born, then the real object has come into the real world. So that is when we are actually using the constructor. So we are objects of person class, and the person class defines many behaviors. Like say for example, when we are hungry we eat, when we are thirsty we drink. So these are all the behaviors that are defined by the person class, but the article in the Wikipedia won't do those activities, right? We as objects will do that. So our real objects exhibit behaviors, okay, whereas the classes define the behaviors. And also each object has some state, okay, like how much weight we have, and how much eyesight we have. So all these are different properties that a person will have. So eating is also one of the behavior that a person class has to exhibit, because of which we all exhibit. And then the KFC. KFC is an object of restaurant class. Okay, restaurant class will not do anything. Restaurant will not do anything. A specific restaurant like Amantran, McDonald's, or some other Absolute Barbecue, Barbecue Nation, these exact restaurants will actually help you do that. So those are the objects. Okay, the specifics. Whereas the restaurant class is just a definition. What should be there in the restaurant? Assume that there is a law in Indian government as to what a restaurant should have, and all that is just a definition of restaurant. Okay, you're not going to get food by them. You're actually going to get food by the actual objects. Okay? And also it defines that the restaurant class defines serving, home delivery, etc. extra behaviors. Whereas the KFC is one such restaurant which actually exhibits that behaviors. Okay, like serving, home delivery, blah 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 blah. And then the third person, Bobby, is an object of chef class. Okay, what should a chef do? The chef class defines, okay, he has to be able to cook many things. He has to be able to turn on the stove. He has to be able to use all the ingredients. So these are all the different behaviors a certain chef class will define. And then actual chef, if that person is trained, he will be actually working as an actual chef. Okay, so he is an object, whereas chef is a generic class. So now, as I was telling, the person class is just a definition, whereas George Bush, Abdul Kalam, Bin Laden, and you are the person objects. Okay, the objects that are created from the person class. Okay, various properties we can have: height, weight, age, name, etc. And then various behaviors that we have are like sleeping, running, eating, drinking, and dreaming, daydreaming, whatever. So all these behaviors are defined in the person class and exhibited by the actual person objects. And then the chef class. Now, if you see, the chef class is also a person. Okay, so you don't actually have difference between a chef class and all. But what you see is chef is like an extension to person class. Don't you see? Chef is also a person. So and then but he will exhibit some extra behaviors, like he knows how to cook some Italian specialties, etc. So chef is also no different from person class. He will exhibit all the behaviors that are defined by the person class, and he will do something slightly differently. Okay, cooking you will do differently, whereas the all the chefs will do slightly differently, assuming that you don't know much of cooking. And we can say, we can very safely say that chef class is a theoretical template and is a subset of a person class. Okay? And it has the regular properties that are defined in person class, like height, weight, age, etc. And then it also defines its own properties, like specialties. What are all his specialties? What cuisines can he cook? And then also behaviors. The regular behaviors of a person will be there, and it also defines its own behaviors, like mentoring other junior chefs, cooking. So all these kinds of things will be there, and also cooking will be there in person class also, but the chef cooks it slightly differently, right? So the chef class cooking behavior is actually going to override the person class cooking behavior. So we will see all these things in actual programming sense. But for now, uh, hope you understood the concept of what is a class, what is an object. So you're clear on that, Srinivas and Kishore?
Yes, Buddha. Yes, Buddha. Clear.
So now let's come to the concept that I said I'll be covering today. One is inheritance. So the concept of inheritance is what I have already explained to you. The chef class is extending the behaviors and properties of the person and having its own methods, or even overriding the existing behaviors of the person class. And how he see the sample example of how the chef class can extend a person class is shown over here. Public class chef, that all you know, and how to create a class and all you already know. And to extend all the behaviors of a person class, we simply say extends person, and that's it. All the properties that are there in the person class and all the behaviors that are there in the person class will also be part of this chef class, provided that they are not private. Okay. And then inheritance is actually a process where in which a class has to acquire properties and behaviors of other class. Okay? It's simply without actually rewriting that all code. So it actually represents is a relationship. Okay, what do I mean by is a relationship? We can say chef is a person, right? And it's as good as that. When we say inheritance, chef is a person. Imagine in the real world, you have created a class called vehicle, and then you have created classes called car, truck, and bus and train. If you say car is a vehicle, bus is a vehicle, train is a vehicle, and any other things that you create are vehicles. So they all have some basic properties, okay, like horsepower, like seating capacity. All these things are there in every vehicle. Okay, how much load it can bear, and all that kind of things. And the same properties can be extended by all these child classes without actually rewriting that code. And when we said child classes, as I said, child classes can access methods from parent class, and they can also override some behaviors of the parent class. So that's how we can use something called as inheritance. And then let me just show you an inheritance demonstration. So now let's say we have this game class, okay, and this game class constructor, what it is doing, it is actually creating all the words in its own, and then the new game method is actually doing some things in a slightly different fashion, doing some things. Okay, let's not worry about what it is doing and all. Let's say there is another flavor, another game, okay, another flavor of the same unscrambler game. So let's call it Fiery Fingers. So the Fiery Fingers game works like this. User will be asked to give a specific time as to how much time he wants to play the game, and then when he chooses a specific time, he will be given words constantly one after another. Okay, we don't really care about whether we gave that already or not, because here our words are limited for now. And so we'll be giving one after another. When the user enters correct answer, even if whether he enters correct answer or not, we will simply go ahead and continue. And then at the end, let's say we will be telling him how many he won, how many he lost. Okay, so now for that game, let's create a class called as Fiery Fingers, and then we finish it. Here, what did I say? We want to have all these behaviors of this class. Like we want to have the behavior of finding the random word and all everything. We don't want to rewrite that code. So in order to do that, in order to achieve that, all we have to do is we simply have to extend game. When we write like this Fiery Fingers has got all the properties that are there in the game class. So now let's see what exactly I mean by that. Let's say I'm creating Fiery Fingers FG new Fiery Fingers. Okay, here there is no confusion, right? We created a class, but then now I'm giving FG here. Now how did I get this new game? In my Fiery Fingers dot game, I have not written any that game. If you see, the Fiery Fingers class has none of those methods. Okay, but I still got that. So fg dot, if I say new game, I have this. If I say, is there any other, there is set random index which is actually not public, so we cannot use that. We only have new game method that we can actually write, okay, use for now. So now what shall we do is, this new game behavior, what we are trying to do is, the fiery fingers will have every other behavior exactly same, like creating objects and all, except the actual new game method will be different. So for that to happen, what do we do is this: public override void new game. Forgot the syntax. Okay, so we don't have to use that keyword override. We simply have to put this annotation, and even if you don't put this annotation, that is fine. We simply create the same method with the same signature. Then that method will be automatically overridden. When we actually call super.newGame, what actually it means is, we'll be calling the new game method from the parent class. Now let's say, so let's say we want to assume, we want to run this particular super.newGame repeatedly, like whenever user has entered a word, we want to actually call this one. So what we can actually, let's first see simple example. This out 5 fingers. Now let's run this program and see what will be the output. Now see, and if you see this output, this is fiery finger. So after this, hey Buddha, hooray Buddha, you solved this problem in 3.5 seconds, which comes from here. Okay, after this new game method is executed, we actually executed some extra code. So this is how we can actually extend the functionality. Okay, now what did I say? We will actually ask the user to enter some time. Based on the time that he enters, we will be repeating the same game as soon as, until the time is over. Okay, and then at the end we will be actually calculating, or for now, let's say uh, this new game is not actually returning anything, so this fiery fingers will not know whether the user has won the game or not. So now what, let's do some small change. Let's return a boolean whether, based on whether the user has won or not. Now what happens is, we are going to return true, and then we are going to return false. And now what we are going to do over here is, we will be repeating the same object, and because we have changed the signature in the method, in that game method, we have to change here also. So then only it will be overriding, otherwise it won't be overriding. Now here we will be simply getting that particular thing, like we will be simply repeating. What we can actually do is, we can actually call the same method again and again. For first let's actually ask the user how many. Okay, let's do this. Let's call this limit as, say for example, 15 seconds. Let's put that manually. Let's not worry about reading from scanner, we already know how to do that and all. And then what we will do is, instant start equals to instant dot now we'll be repeating until duration dot between the start is start and end is instant dot now dot 2 millis is greater than limit into 1000. So whenever the limit has reached more than 15 seconds, whenever, as long as the number of time seconds that took between the starting point and now is less than 15 seconds, the super dot new game will be called. And control Z, boolean result equals to if result now. What this does is it will be simply calling the existing functionality and overwriting that, and also finally we will be printing total wins total losses. And that's it, we got a new game, and without having to write any other code, we actually extended that existing functionality, thereby reusing that code. So now if we have to repeat everything here, this same functionality will become, instead of this 15-line code, it will become 50 to 60 lines of code, because it's actually around 20 lines of code here. Okay, so now if we run this program, main program, what happens? What's your name? My name is Buddha. And then Fritz. And then and then piano. And then my time has run out. So total wins are 5, total losses are 1. And do I want to continue? No. So I want to quit. Now I have exited from the game. So have you understood the concept of how we have got other functionality of this game method? Here we have not actually used this set random index over here. Okay, in fact we can use that also if we want. Okay, we really did not have to call this super dot new game method. Okay, what we could have simply done is we could have also have this here. Now instead of return result equals to true, and here result equals to false. Now what happened is we got the same functionality, but we have not actually called that. And now if you see closely here, this is not actually in new game, this is actually fiery fingers. Okay, and now if I run this method, now I should be able to, what's your name, B, and it says fiery fingers new game, and then I'm playing the game, and that's it. It's actually as good as So now I win slow 4, losses 2. And now if you observe closely, I'm actually using the set random index method here, but I have not written the set random index method. And how did I get that? I got that, and also I'm using these words directly. And how did I actually got that words? I don't have any words variable here. I got that because I'm actually extending game class, and in the game class, the words and the set random index, they are not private. If they are private, we cannot use that. Let's say this is private. Then what happens is in Firefingers we could not have used this set random index. Okay, but if you have actually called this like this, super dot new game of name, then it won't be any error because that set random index is being used only inside this game method. So even if it is private, it works because it doesn't care about set random index, right? As long as the super class new game method is working for it. So if we want to make sure that we use that properties and the fields and the methods here, they have to be either public or they have to be protected. And now this brings me actually to the slide that I might have left some things earlier. In the methods and classes section, there is protected, which I have actually not explained to you. Okay, so this is where protected comes in. If I make a specific method protected, I will be able to use that method over here without any error. Okay, but because this is actually public, sorry, this is actually private, I cannot use that. So now protected. Now what's the difference between this and private? Private doesn't even allow you to use that here in Fiery Fingers. Okay, whereas protected is like a slightly lesser restrictive version of private. So any class that is extending that class can access the methods that are protected, methods or properties that are protected. And also, what did I explain in that slide? If the default means any classes that are in that same package can access those things. So default means not giving any specific access modifier. Now if I open my Eclipse, if I don't give this protected also, what happens is I will be able to use this set random index in Fiery Fingers if I want. Okay, however, if I have created any class over here and I create an object called, say, for example, or let's say I'm extending a class here, new class sample extension, and then assume that I am actually extends game here, public void. Now here I want to use set random index. I cannot use it. First I have to import it, right? Import game. I cannot use it. However, I can actually use new game. Why? Well, how could I actually use new game? Because I'm actually extending this game class. I have all that functionality ready made here. But because that is given a, that set random index has given a default access, I will not be able to access because these two are in two different packages. So that is what default means. So if I have this public, I can access it anywhere. If I have private, I cannot access it anywhere else. And if I have protected, I can access in the classes that are extending from that class. Now if I made this private, now if I type set, I will be getting that. Okay, so now this is how the access modifiers and extensions work. So this is the concept of inheritance. So there are different types in which an inheritance can take place. One is the person class. Chef is a person. Okay, and which means chef is actually coming from person. And also, let's say there is another even specialized chef. Let's say Italian chef. So Italian chef is actually extending chef class, whereas chef class is extending person class. In that case, Italian chef is also indirectly extending the person class. That is called as multi-level inheritance. The simple inheritance that we have seen is single inheritance. And then there is another type of inheritance. So say for example, an Italian chef may be extending from chef class and then also extending from engineer class. This is called as multiple inheritance. But in Java, this is not possible. Okay, Java has restricted you from doing this because say there is a method called cook in chef as well as a method called cook in engineer also. Okay, so engineer will be cooking some uh, what is some chemical, whereas a chef will be cooking some eatable. Okay, so now I'm calling that particular method cook in Italian chef. Which cook do I have to call? How can I tell call from this or this? There is only one super. Super means get from the parent class, but here both chef and engineer are parent class to this Italian chef, so there will be a confusion when there is a multiple inheritance. So Java actually restricted from you to extending from multiple classes. Okay, so that is what that's how you will have to, you may be asked some interview question about whether multiple inheritance is possible in Java or not. In that case, you clearly tell no, it isn't, because of the example that I just told. Okay. So there is another kind of relationship between classes. Okay, what we have seen is to get the functionality of other classes, we have actually used something called as inheritance. But there is another thing called as composition. In fact, have been using this composition from the beginning. Okay, it's not new actually. You are using composition since beginning. Composition is nothing but creating an object of that other class. Okay, so even then you will be able to achieve the same functionality without having to worry too much about uh, getting the or writing the rewriting the code. Okay, it's also known as aggregation, and it is also in short form it is also called as has a relationship. Okay, now restaurant has a chef, has utensils, has stove. It is not extending from chef or utensils or stove. It has all these, so it has all these objects in them. Okay, so the actual KFC restaurant will have the chef objects, utensil objects, stove objects. Okay, so this is another way of reusing the code. So let me show you a simple way of reusing the code. Now I have created, I've reused the code of this game method by using what the by extension. Right now, let's say I don't want to extend this for whatever reason, but how can I actually do the same things? Now I can create with same name or different name, it doesn't matter. Now I'm not overriding it. Instead, what I'll do is I'll create a game class here. Game G equals to new game. And now if I want to use G dot set randomly, I cannot, because that is protected. I cannot use it outside. Now what I'll do is instead of calling super dot new game, I'll be saying G dot new game. That's it. This is called as composition. So you don't actually extend, but to actually reuse that functionality, what you will do, you will create the objects of those classes, and everything else works just same. Okay, so then what is the advantage of actually using extension? Extending actually simplifies some of the things, wherein I'll tell you just now it is working as I explained. So the difference between extension and composition is that first thing, you don't have to obviously create an object, and second thing, you can also access the protected methods which are not accessible anywhere outside. Okay, and the you can also use some of the fields that are there directly without having to worry about recreating them or recreating that states in your class. And what else? That's the advantage of using extents. Okay, you will be able to reuse many of the things even if they are protected. If you create a class like this, you cannot call that set random index. You cannot call that set random index. It may be showing you, and now when you use that line, I'm sorry, why did it? Did I make it default? I think so. No, this is not default, and then this is okay. I'm actually using that set random index. Oh, okay. I'm actually using it from that from a different object. Let me just run this. Why is it allowing me to go ahead and use it? Okay, I'll check that why I'm able to access protected variable, but you cannot directly call those methods without having to uh, create the without having to create the object. So that is the difference between using the composition and using extensions. Okay. So inheritance is something where you can only inherit from one class, whereas composition you can create from multiple classes. Let's say you have execute query class here. Don't worry about what that is doing. So you can create actually get that same functionalities from multiple. Now you can also call the methods from those classes. So get result with JNDA, all those things. So now what's the difference that you have seen between with composition and in composition you can actually get the functionalities from multiple things. Okay. Anyways, you can also mix up inheritance and composition. You can use this extends game and then use this composition. There is no rule that you have to only use one of them. Okay, so it's always about the requirement that you have. Sometimes extending will make things simple, and sometimes simply composition will make things simple. Okay, so there is no single way of achieving things. Okay, so it's always about some matter of choice and also sometimes matter of efficiency. Okay, so always take the decision when you actually have to do that. Okay, now I see why that may be throwing an error. Why there is problem? Invalid content found. Okay, still letting me access it. I'll come back to you on this accessing this particular accessing the protected methods. So, have you got any other questions on these topics of inheritance and composition?
Yes, Buddha. I mean, like you said, for composition,
Mm-hmm.
we cannot access protected variables or private variables.
Yes, yes, that's true.
So in a class, if every method and variables are say private,
Okay.
uh, so how can I composite that one? I mean, how can I, instead of
No,
extending, how can I use that one?
no. When someone say, let's say someone created that class, why do they
Mhm.
want you to want to make everything private? what exactly that class supposed to do? It's always about that. Okay, if someone has developed something, if they
Mm-hmm.
want you to use it, okay, if you have to use it, they would have made something public, that the ones that you can actually use. Okay, so
Okay.
if they are not public, you cannot actually use that. There are ways to use even the private ones, but that is not safe, and that is actually breaking the rules of object-oriented programming. There is something called as reflection API, using which we can also call the private methods and all, but trust me, you really don't want to go to such a length of trying to call those things by using that one. Okay. So ideally, you should not be calling the private or protected methods.
So in other words, I can use composition only if there are any
Yes.
public methods or variables.
Yes. Okay. Most of the time there will be public methods. Okay. I've not seen so far. I've not seen any single class that doesn't have a single public method.
Mm-hmm.
Okay. So imagine at least he has to make constructor as public. Okay.
Okay.
Imagine a case where you will, when you create an object, say for example, let's say you're building a virus. When you have actually created an object of the virus by using the new virus constructor, and then once it has been started, assume that you don't have to do anything. The virus will take care of corrupting your system, creating all the files and everything, and the constructor itself will be doing everything that you need. So
Mm-hmm.
you won't be really using that functionality by calling them, but internally when you actually create that object, everything happens automatically, right? Okay, the constructor itself will be calling the all the internal private methods and all. So if the constructor is public, by calling that, if the all the classes are private, then you will be using it. Okay, the reason why they have given you private is because to restrict you from using those those private methods. Okay, if someone wants you to use them, they will be making them public. If you use some reflection or something by and breaking the will of that person and use that by force, yes, you can do that. You may not be getting the results that the developer has been uh, providing you with. Okay, imagine say you have brought a microwave oven. Okay, that's an object that you brought. Okay, what are public? The buttons that are given to you are the public ones. Okay, if you select certain temperature, to select certain temperature, you are actually using the buttons and all, right? What is private?
Yeah.
How that circuit board is operating is private. Imagine that you want to go to the length of opening that microwave oven and trying to pass signals at right points and provide certain voltage to increase the temperature. Yes, you can do that, but are you really achieving what you want? There may be some side effects also. You may be, it may short circuit, it may be not be doing some preconditions that you are supposed to, you may not be doing those things. So all these things, the private things are uh, created as private for the specific reason, because to avoid complexity. Okay, you, yes, you can use that, but you can use something called as reflection to access private things, but generally, unless there is no other way, it's not suggested. Okay, we will see reflection if needed at later point of time. At this point of time, we don't really have to worry about that.
Okay.
Okay, any other questions? Tell me one thing, in this game class, why did I make these things protected? Why do I really want to make this scrambled one protected? I can make this public and let my game class directly call that scramble, use that scramble variable. But by doing that, I'll be actually opening doors for others to corrupt some things by purpose or by accident. Let's say I made this scramble, and now let's say in my program I accidentally made fb dot scrambled. Did I make it public? Yeah, I did public. fg dot. Why I'm not able to access it? Okay, let me do one small thing. Okay, okay, I'm not extending. Oh, that's right. Okay. Now I came to the point where I was extending back. Now I should be getting those things. And now let's say I have used fg dot scrambled. Now it is public, I can access it. Let's say by accident I have actually set this 0 to A, B, C, D, and then fg dot scrambled of 1 to D, E, F. Let's imagine I did something like this. 1, 2. Now assume that I did something like this. What happens if I run this program? Whatever output answer I give, I'll be getting it is a wrong answer, right? So now what exactly did I gain by making this public? I actually gained uh, the others are actually misusing whatever code I have written. Okay, obviously they are not going to get the results I want. So that is why I don't want this scramble to be used outside. That is the purpose. I don't want this scramble to be used anywhere outside my class. So I make it protected on purpose. Okay, so that's why the reason. And now if I make it protected, I will not be able to access those things. What's happening? Why protected things are? I must have used something. I'll come back to you on why I'm able to access protected. I must have tried some Java patch or something which might have corrupted these things. But ideally, you should not be able to access any protected outside of that class. Now, if I run this program, because I'm able to access the scrambled array, I'll be doing that. So that's why I'll be making them either protected or private. Why would I want to make it protected? Because I want these to be accessed the outside of the uh, okay, now I understood what may be happening. So protected also has the properties of default. Now let me move it to this package, and now let me see what happens here. Now fg dot scrambled. Okay, now I understood what the problem is. The protected and default actually share something. When I say protected, it also has default inherently. That's why I'm able to access those things. Now if I say fg, because I after I moved it into a different package, when I say fg dot scrambled, I'll not be able to access that one. Okay, because this is protected, and protected also works like default. So we are able to access things that are in the same package also, which is not something that I have actually anticipated. But I'll check and come back to you. Maybe there is some small difference in the latest versions of Java. Now, for now, for you, in most practical purposes, protected can only be accessed within the child classes that are extending that class. Okay, so that's about the inheritance, extensions, protected, default, etc. Any other questions, Srinivas or Kishore?
No, but
Okay, so now let me go to another concept called as abstract classes. Okay, so far we have been creating classes which are whole, okay, which can work in whole. So abstract classes are not complete. Okay, they are classes that contain definitions for some methods, but they don't actually have the method body for them. Okay, so why do we do that? We cannot create objects of abstract classes. Okay, uh, why we want to do that? Why we may want to do that is because sometimes this new game functionality, whatever that new game method functionality, I don't really want to put it in game. I want the user to create his own game, and I want him to actually provide the functionality or the actual logic for that new game method. So in such cases, what I'll be doing is I'll be creating a method as an abstract method, and then the class that contains that method will become abstract. Okay, we cannot instantiate, so we have to extend some child classes, extend the classes in child classes, and provide the definition for those abstract methods, and then only we can create the objects of them. Okay, it will not be clear now. When you actually see the example, you will actually understand. Let's say there is a game class which is actually being extended by the child class called a simple game, where one method I made it as an abstract. Okay, which means I'll be telling that I'll be writing the method name and signature, but I'll not be putting the actual logic for that. The method body, that brace and all, I'm not putting that. By making that way, this particular start method actually becomes an abstract method. What exactly is the meaning of abstract method? When the method is abstract, the class is also abstract. And then when I say abstract and when I extend that class in simple game, I will have to provide the method body. If I don't provide this, it actually becomes a compiler error. Or this simple game will also have to be a, what did I say? A simple game also have to be an abstract class. Okay. So when I do that, I can actually create objects of simple game, not of game. Okay, but why did I actually do that? I did that because I don't want to create any specific functionality approach for the start method, but I want to use some create some method get points that I want others to be able to use that through this simple game method. In that case, what I'll do, I have created method body for some methods, whereas I have not given method body for some methods. That way, the compiler will actually make me do that. Okay, that's the main point of this whole Java rules and regulations. Okay, that actually avoids some mistakes, so that it will, because it will not compile unless we provide this start method definition. Okay, now let us make this game class as abstract class, then you will understand more. So now there is this new game method which I don't want to create any definition for this over here in game method. Okay, instead I want to make this abstract. So when I make this like this, what it says is I have to change it into an abstract method, and that, which means I have to just add this abstract keyword here and save it. And why is it still telling the abstract method can only be defined by an abstract class? So which means I also have to put that abstract keyword for the game class also. So now this game is abstract. If I go to main method and I try to create a main object, game g equals to new game, it will throw an error. It says you cannot create game object because the game is not in that package. Okay, let's say we have imported that. So now, okay, now still we cannot create object of that. Why? Because the game is an abstract class. But then what can we instantiate? We can instantiate the child classes if we actually provide the definition for the new game method. Now we are already providing definition for the new game method, but this actually doesn't contain any specific logic, right, of conducting a game. Now I am doing that. Wait, result equals to true, result equals to false. Now that's it. What happened? The fiery fingers actually is extending game and assume that we have not provided any definition for this new game method. So now this is not new game method, right? And let's say I have not given this. Now what happens? Now my code will not compile. There will be a compiler. When I put the mouse over here, it says the type fiery fingers must implement the inherited abstract method, or this method has to be abstract. So now if I say abstract, now my fiery fingers also becomes abstract. Now I don't want that. So what I want is this. I want to create or override the method which is not been created in the game method, and that's it. We have a game abstract class where the actual definition is provided in my fiery fingers class. Okay, so now because my game is abstract, we cannot create object of this game, but we can create objects of its child classes, or we can create variable g using which we can actually instantiate the object of child classes. For now, for the sake of simplicity, let's create both same type as variables and objects. Now when I say fiery fingers fg new fiery fingers, everything works just like just the way it worked before. Okay, so this is why this is how we can actually create abstract classes and provide definition for the abstract methods in the child classes. Okay, if we don't provide this new game method, that's a compiler error, because this is not abstract, so there cannot be any abstract methods at all. And that's how we can actually create abstract methods. Okay, and one small thing that you will have to understand is, we don't really have to create. See, there are two things over here. One is object, which is created by this, and another one is the variable. This variable is a different thing. It's like, if you are aware of C programming language, you know that there are something called as pointers. So this FG works like a pointer. It simply points to an address location, where that address location is the place where this fiery fingers object is located at. Okay, it's like having your address stored in your contact. Okay, so having that contact is like, just know where it is. Okay, if you want to use, you have to go there. That way you have to actually use that object. Okay, so to use that object, you are actually using this FG variable. Now this variable actually is pointing to this object. This variable can also be game. Why? In Java, when we actually create a class by extending from some parent class, we can actually use the parent class variable to store the or refer the object of the child class. This works. But what is the difference? Why do we want to do it this way? Say there is another flavor of the same game, multi game. Okay, so for after some time, we actually want to change that FG to multi-game. You may say that we can create a different variable also, but imagine this is the requirement. You will have to do it this way. Now, what happens is, if you have created this as a fiery fingers, you cannot actually assign this to this. Okay, but because the game class is parent for both fiery fingers and multi-game, it can refer to both of them. Okay, now this error will be gone. So that's how you can actually create a parent class and then access them. Then what is the difference? What difference does it make? Let's say I have a class that is specific to fiery fingers. I mean method. Now in my main method, if I say fiery fingers here, I cannot do this. If I say fg dot method, I will be able to access that method. Now imagine, instead of using the parent class, that class, we have used its parent. Now if I use fg dot, I'll not be getting method. Okay, so if there are any specific classes that you will have to access in that from that class, you should not use its parent class reference variable. You should be using the fiery fingers itself. Okay, and that's the difference between using a parent class as a variable. Use that when you have a chance of using the same variable, or chance or requirement to use the same variable for accessing or referring another class also. So then you will actually use this. In Java, every class is actually coming from a class called as object. Okay, now if you see this main class, I'm not extending from anything, right? But still, inherently in Java, it becomes something like this. Okay, so object is a class that is a base class for everything. If you see, this class is the root of the class hierarchies. Every class, whether you mention it or not, will be extending from this. Okay, how? By using the multi-level inheritance. If you remember, I've shown you a slide where Italian chef is extending from chef is extending from person, and ultimately after some levels or in the next level, the person will be automatically extending from the uh, object class. Okay, if you say object here, you will be able to refer this variable using this object. But because object class does not know about this new game, which is only defined in game method, you will not be able to access this new game. So in some cases you will be able to access these things. Now let's say, now in this case, if I want to use, then how do I do that? I have to convert it. So now when I do it like this, now when I what I did over here, I have converted this FG object type of FG to the game type. Okay, so this is called as casting. So when I casted this object to game, then this new game is visible. So that is how you will have to be using parent classes and child classes. You will see some examples of the same kind of things when we are working for on generics and all. But for now, just understand the generic idea. Okay, now let's see, there is another type, okay, which I have not yet covered, okay, which is in interfaces. Okay, interfaces is also very important topic. Interfaces are also like parent classes, except that in interfaces you cannot have the method bodies unless the methods are either static or default methods. Okay, and everything that is there in the interface is public, and that is, you don't have to mention the abstract keyword, and they are all implicitly abstract. So that let me just show you what is the inheritance interface, then you will actually, it will actually make sense. Now let's say, instead of making this a class, or I can actually make this as an interface. When I make this interface, I cannot mark this as protected. Okay, I have to make them public, or even leaving them default will make it public automatically. Also, I cannot have any constructor over here, so all this code has to go somewhere. Okay, let's not think about that. And what did you say, it may not have been initialized, so let me create this. Okay, let me not actually create a game as the interface, it actually confuses sometimes. I came back to the previous section. Let's create a interface. And here what I'll do is, interface is like a contract. Okay, so it's like giving a requirement. When I say public void method 1, nothing happens. Okay, you don't get any error. Now what the difference comes when we actually implement this interface. Let's say we have another class that wants to make use of this interface. Now to do that, how I can do this is, we can say implements and give that interface name. So now what happens is, my class will get an error. So I have to implement all these methods that are there in the test interface. Now when I say implement, I have to write the method bodies for those. Now when I write the method body, I'll be actually getting it. Now what is the advantage of actually using the interfaces? When I say classes, we can only extend from one single class, right? But when we say interfaces, we can actually implement from multiple interfaces. List is one interface that you may be able to use, or say for example, if you, let's say line, let's not worry about what that line is, etc. And now let's say this interface implements both implements test interface as well as line. The line should have some methods. When we say implement, it has so many methods, all blank methods we got, so we have to write the code if you want to use these things. But the main point of me coming to show here is, I have created a class which is implementing multiple interfaces. Then what is the advantage of using these things? Okay, interfaces are like marking. So now I'll be able to access refer multiple classes using this interface names also. Like how I am using parent classes to create these, I can use using interface also. Let's say here test interface. Normally, how do you create the object? Interface implementer, right? Interface implements, and I equals to new interface implements. Now, instead of using this object, I can use both test interface as a variable as well as line as a variable. This way, it actually gives me, I have to say Java X. Now, what actually happens over here is I'll be able to access all the classes refer all the classes that are implementing this interface by using this I. So this is the advantage we will be getting if we actually use interfaces. So we will be able to access it. It actually major advantage that you're going to get is you will be getting a contract. Let's say you have to ask a developer to create a specific method. What you can do is you can create an interface and then give him that class. Okay, give him that interface, and then you ask him to actually uh, create a class implementing that interface. So what he has to do, he will automatically understand that, okay, if I have to implement this interface, I have to provide bodies for this methods. Then he will be providing that. Unless he provides that, the compiler will be throwing an error saying that, boss, you have to implement these methods. Okay, so that is how we will be able to access the use the interfaces. So interfaces are also like abstract methods, except that you can implement from multiple interfaces. Okay, in interfaces, say from Java 8 onwards, that is latest version of Java, we can also provide method bodies, method set to. We can provide some method bodies, but these have to be default methods, public default void, and I'm sorry, I must have used public void default. Okay, I can use a default keyword to actually tell that these methods will be there by default in all the classes that are implementing this. So in some sense, you can also use these like abstract classes, but they have added this default keyword for a specific purpose. But I don't want to go into that details at this point of time. Let's say our project, I made this 1.8 to 1.7 compliance level and applied. Then what happens, if you see, it won't allow me at all. Okay, default methods are only allowed at source level 1.8. So the recently released Java version only contains this default methods, otherwise you cannot. Okay, so static methods, so you can also create static methods only in interfaces, but only in 1.8 version of Java. Okay, so that's one of the reasons why I actually asked you to install that. And also your intention is to go for certification of Java 8, right? So this may be an important concept. So what is the new thing that is coming in Java 8? So even how do you test the difference between Java 8 and Java 7? All you have to do is right click on your project, go to properties, go to Java compiler, and you compliance level. If you change it to 1.7, that class will be compiled with the 1.7 compiler, and you can even go to previous versions also. Okay, some functionalities may be disabled if you go to that previous function versions of Java. Okay, so that's the you can create either static or default methods, so that they will also be available in the classes that are actually implementing these interfaces. So that's about interfaces. Okay, so I actually want you to research about singleton on your own. There is a concept called a singleton. When we actually are discussing about classes, generally any developer will be knowing some things about singletons. Okay, so I actually want you to research about singleton, and I want you to make the game class as a singleton class. Okay, I'm not telling you what singleton is. It has something to do with these classes and all only. But along with doing some exercise on I'll try all these code examples I tried in this session, and also try to do this exercise during the weekend. Also, Kishore tried to finish those things during this weekend, the previous ones. Okay, so otherwise it
Yeah, yeah,
gets
Buddha.
tougher and tougher as we go forward. So that's it. I don't have anything else to cover in this session. So do you guys have any questions?
Buddha, then what is the difference between interfaces and composition? Even there, we are using multiple
No,
So,
the composition is simply creating objects. Okay, but see, the difference is this: if you have an interface, and if in your method, if you are not implementing, where is that? Okay, if you are not implementing that method, it is going to throw an error. But in composition,
okay.
are you going to get any help like that? Let's say I have to create, say for example, this words class, or say for example some other class of fiery fingers. So this is protected fiery fingers. F equals to new fiery fingers. Now this is composition, right? Now whether I do this or not, do I get any help? Like, do I get any error? I have not
Um,
kept it. No, I have not got error. I kept it. Did I get any error? No. But when I actually use interfaces, okay,
mhm.
if I don't write any specific method, it is going to throw me an error. So interfaces are going to help you so that you don't make some mistakes.
Okay.
Okay. So any other questions? Okay. So try to do those exercises and see if you can submit in Edmodo so that you will know what all you have done. And also go to that Edmodo group. You will know what all exercises are there so far to solve. I did not add all. I've only added the recent few ones. So try to solve all those that are there, and upload your Java file so that we can discuss about those things once you have done. Okay, so that's for today. So unless you have any more questions, let's have a great weekend. Okay, bye bye.
Okay. Buddha, can you you'll be sharing the file, right? This presentation and the recording.
Yes, yes. I'm actually, if you have not observed, I'm actually uploading them in YouTube and sharing that link in that Edmodo group.
Yeah, yeah, I saw that, but today's presentation.
Yes, yes. I'll do that. I'll do that immediately. Okay, so I'll be just posting it over
Okay,
there.
because okay, sure, okay, thank you.
Okay. Uh,